The chemical context of life. A chemical connection to biology. Like other animals, ants have structures and mechanisms that helps them defend themselves from predators. Research on ants and any other insect is a good example of how relevant chemistry is to the study of life. In this picture, you got the ants defending themselves against predators by shooting things out of their sides. Elements and compounds. An element is a substance that cannot be broken down into other substances by chemical reactions. A compound is a substance consisting of two or more different elements combined in a fixed ratio. Oxygen, carbon, hydrogen, and nitrogen are the most common elements. You will find them basically anywhere. Magnesium, chlorine, sodium, and sulfur are less common. The elements of life. Oxygen, hydrogen, carbon, and nitrogen make up 96% of living matter, making them the most common. Calcium, potassium, phosphorus, sulfur make up most of the remaining 4, making them the least common. Subatomic particles. Protons and electrons are electrically charged. Neutrons are electrically neutral. In the picture, you have a cloud of negative charge, and in the other one, you have nucleus and electrons. Atomic number and atomic mass. Mass number is number of protons plus neutrons, which equal 23 for sodium. Atomic number, number of protons, number of electrons in a neutral atom, 11 for sodium. 23, in other words, 23 for sodium in mass number and 11 for atomic number. Number of neutrons, mass number minus atomic number. So 23 minus 11, making it 12 for sodium. Electronic distribution and chemical properties. The chemical behavior of an atom is determined by the distribution of electrons in the atom's electrical shells. Electrons, like all matter, tend to exist in the lowest available state of potential energy. In this picture, you have the hydrogen atoms slowly combining. Bonds. A covalent bond is the sharing of a pair of valence electrons by two atoms, and two ions of opposite charge can form an ionic bond. Many large biological molecules are held in their functional form by weak bonds. The attraction between a hydrogen and electronegative atom is called a hydrogen bond. In this picture, you have them forming. Molecule shape and function. A molecule has a characteristic size and precise shape. Most molecules with more than 2 atoms have more complicated shapes, like in this image. Chemical reactions make and break chemical bonds. The making and breaking of chemical bonds leads to changes in the composition of matter, and that is called chemical bonds. The point at which the reaction offsets one and another one is called chemical equilibrium. In this picture, you have H2 and 2O both forming, giving a chemical reaction, making H2O, in other words, water. That's all.